So, question 6. It's given that the angle theta satisfies that equation. Show that tan 2 theta is equal to a half. Lots of ways that we could have done this. The most common way that people did this was to multiply out, or expand the brackets, not multiply out particularly. So that's sine A plus B. So that's sine A cos B plus cos A sine B. And then we've got cos A cos B minus sine A sine B. Oh, nearly run out of space. I have run out of space. Oh, this is all going wrong now. Oh no, I've lost the S from there as well. Oh, I've deleted everything. There's no way back from this. It's all right. Right. Okay. Have I got everything in there? That's a sine pi by 4. There. Okay, that looks all right now to me. Right. Cos pi by 4 and sine pi by 4 are exactly the same thing. So, although we could now write that it's equal to root 2 over 2 all the way along, it's a common factor of every term, isn't it? Every term would be multiplied by root 2 over 2. So we could just get rid of the sine and cos. If we divide everything by root 2 over 2, then we end up saying that we've got sine 2 theta plus cos 2 theta is 3 cos 2 theta minus 3 sine 2 theta. And we get that quite quickly out of it. At which point we're after tan, so we are going to divide everything by cos 2 theta. So tan 2 theta plus 1 is 3 minus 3 tan 2 theta. And we're going to collect like terms. We've got 4 tan 2 thetas over here is equal to 2. So tan 2 theta is equal to a half. And we've done it. I might have done it that way. I might actually have thought I'm going to divide by cos 2 theta plus a quarter pi at the very start and get tan A plus B equals 3 and do the tan A plus B formula because tan of pi by 4 is 1, and that simplifies really quickly as well. So I might have done it that way as well. I don't know in practice which way I would have done. Number of ways to get to the right answer out of this. Okay, part 2 then said, hence find in third form the exact value of tan theta, given that theta is an obtuse angle. So we're starting from tan 2 theta equals a half. Now we don't want to find theta. We want to find tan theta, and we know our tan double angle formula. Tan 2a is 2 tan a over 1 minus tan squared a. So we've got 2 tan theta is a half of 1 minus tan squared. We're heading for a quadratic in terms of tan theta. I'm going to double everything. 4 tan theta is 1 minus tan squared theta. So tan squared theta plus 4 tan theta, I'm supposed to say tan, minus 1 would be 0. We're not in detailed reasoning, so we can legitimately go to our calculator and solve that polynomial of degree 2 in terms of tan theta. So that's 1, 4 and negative 1 as the coefficients, giving us minus 2 plus or minus root 5. Tan theta is minus 2 plus or minus root 5. The question said, find in third form the exact value of tan theta given that theta is an obtuse angle. If we don't know this straight away, we do know that the tan curve is going to do something like that, where that is 90, that is 180, there's 270 and so on. Now actually, if we're talking about an obtuse angle. Obtuse angles, there's only a little window of what things can be obtuse angles. That's it, isn't it? If it's an obtuse angle, it means it is between 90 and 180. That's it. No other argument about what an obtuse angle is. And in order for that to happen, tan theta must be negative. So the only negative value we had was -2 minus root 5, because -2 plus root 5 is positive. So that was the answer. And the only answer. And that's maths.